The other way of preparing a solution is by dilution, which is just adding solvent to an existing solution. And anytime you add solvent to a solution, dilution will decrease the concentration because we have the same amount of solute dissolved, but now it's spread out through a larger volume. Okay, so if you're using a concentration like moles per liter, you've got the same number of moles, but now more liters that it's dissolved in, the concentration decreases. Okay, so anytime you dilute something, your final concentration should be lower than your initial concentration. That's what a dilution is. And anytime that a dilution is happening, right, by being aware of seeing that word in a problem, dilution, or if your problem is ever just talking about adding water to an existing solution to change its concentration, you have to use the dilution equation. And the ones here are what you had before the dilution, and the twos are what you get after. So concentration, volume before, right? So the concentration of your original solution, how much of that original solution you need, the new concentration of your resulting solution, and the new volume of your resulting solution. So you'll always have three pieces of information there, and you'll solve for the fourth, just using a little algebra to solve it. So this is the question that we'll do right here. How do you prepare 500 milliliters of a 1.5 molar solution by dilution of a 6.0 molar stock solution? And sometimes it's helpful to organize your information into what it is that you already have and what it is that you want to be making. So look at the question, read it until you can make sense out of what's actually being asked there. Okay? You may need to read it a couple of times. As you become more familiar with this process, you'll be able to recognize the language that's used in order to tell what's happening here. But let's read our question again. How do you prepare 500 milliliters? How do you prepare 500 milliliters? That's something we want to make. We want to prepare 500 milliliters of a 1.5 molar solution. We want 500 milliliters of a 1.5 molar solution. We don't have 500 milliliters yet. We will after we do the dilution to prepare it. How do you prepare that? By dilution of a 6.0 molar stock solution. Okay? That's what we have already. We've got access to a 6.0 molar stock solution. And what we'll need to do is figure out how much. We'll need to figure out what volume of that stock solution we need in order to make this particular new solution. So the things we have are the ones, right? Those are the things before solution. So 6.0 molar is M1. I want 500 milliliters. That's a volume. That's V2 because that's the volume we'll have after the dilution is done. And the 1.5 molar is the concentration that we'll have after the dilution is done. So M1V1 equals M2V2. We know M1, we know V2, we know M2. We're going to have to solve for V1. And in order to do that, in order to get V1 alone by itself over here, I'm going to have to divide both sides by M1 because that will cancel it away from over there. So V1, the original volume, the volume of the 6 molar stock solution that I need will be M2, so 1.5 molar, V2, 500 milliliters, divided by M1, 6.0 molar. Okay. For the units, the only thing that you have to be careful about is that your two units measuring the same kind of thing are actually the same. Okay? So we have two concentrations here. Both of those concentrations have to be in molarity, for instance, or they could be both in a different concentration unit. They could both be in like percent. Okay? But they have to be consistent that way because that will cause them to cancel within that equation there. And then all we end up with is Your calculator tells you 125, I think, but we only have 2 sig figs there, so we need 130. The remaining unit here is milliliters. But what does that mean? If I want to make 500 milliliters of a 1.5 molar solution, and if I already have a 6 molar stock solution, what I actually have to do is measure 130 milliliters of the stock solution into a 500 milliliter volumetric flask. Then dilute it to 500. Okay, we're going from 130 milliliters to 500 milliliters, right? So diluting will increase the volume. We're also going from 6 molar down to 1.5 molar. Diluting will decrease the concentration. It'll make it less concentrated. So always check to make sure that your numbers are going in the right direction. That will save you from having set this up incorrectly, right? Mistaken a 1 for a 2 or something like that. The other quick thing that you can do is that the two numbers in your problem that describe the same solution are always multiplied together. So here we talked about how do you prepare 500 milliliters of a 1.5 molar solution. Okay? Both of these are describing that same solution. So those are the ones that will get multiplied, and then we end up dividing by the other one. So that's another quick thing you can use to check to make sure you've got it set up right. So here's another one that'll use the dilution equation. Okay? Just you're solving for something a little different. 75 milliliters of a 12 molar solution are diluted to 425 milliliters. So the volume has increased. Makes sense. What is the final concentration? Why don't you pause me and see if you can arrange M1 V1 equals M2 V2. Actually, first assign the variables to each of these three. Figure out which these are, if it's M1 or V1 or M2 or whatever. Figure out which you're solving for, and then try to substitute them in, and we'll go from there. So in this case, 75 milliliters of 12 molar solution. Those are the things that we're starting with. So 75 milliliters is a volume, that's V1. 12 molars is the original concentration. If it's diluted to 425 milliliters, that's the final volume, that's V2. So I need to solve for M2, the final concentration. Also make sure that the variable that you're missing happens to also be the variable that you're asked about. What is the final concentration? Well, we should be solving for M2. In this case, I'll divide both sides by V2 in order to cancel it over there. Substituting in, we'll have to do M1, 12 molar, times V1, 75.0 milliliters, divided by V2, 425 milliliters. Look at the units here, milliliters cancel, leaving us with a molarity. We're asking about what is a concentration, so that makes sense. The answer I get on this one is 2.1 molar. Did it go the right direction? We went from 12 molar to start with down to 2.1 molar. The concentration decreased as we did the dilution. That's exactly what should happen. So please do some practicing with these kinds of problems. In our course, I have practice molarity practice worksheet right there. Show you what that looks like. It has about every combination of calculations, right? Calculating a molarity, using a molarity as a conversion factor, okay? Calculating mass of a solid. Here's a couple of percent problems right there, a couple of dilution problems. Okay? You can tell this one is a dilution because we're talking about one solution here, or one concentration there and a different concentration of that same solution here. Okay? So give those some practicing, and there'll be questions about this on the next exam.